Hi, this is Alex from devstories.eu. LiteLLM, the Universal LLM Gateway, Episode 7 of 24. You finally got production access to Azure OpenAI, launched your app, and immediately hit a massive rate limit error on your first big traffic spike. You have the quota, but it is bottlenecked in a single region. Load balancing for high throughput solves this. To handle large volumes of requests without hitting limits, you need to distribute your traffic across multiple identical deployments. In LiteLLM, you do this by configuring a router. You group multiple backend endpoints under a single logical model name. Say you have an application backed by 5 Azure deployments spread across 5 different geographic regions. When your app asks for a completion, the router decides which of those 5 regions gets the request. You control this decision logic by setting a routing strategy in your router settings. The intuitive approach is usage-based routing, where the system sends the request to whichever deployment currently has the lowest traffic. But doing that requires tracking exact token usage in real time. Tracking real-time state means making a network call to a cache like Redis for every single request, before the prompt even goes out. That adds a permanent latency tax to your application. For high-throughput production environments, you want to avoid that extra hop. The recommended approach is a strategy called Simple Shuffle. Simple Shuffle does not track live state. It randomly selects an endpoint from your pool based on predefined weights. When you add your 5 Azure deployments to your configuration file, you assign a limit to each one, usually requests per minute, or RPM. You can also use tokens per minute, or TPM. If your primary region has an RPM limit of 10,000 and a secondary region has an RPM limit of 5,000, Simple Shuffle reads those numbers and treats them as weights. It will automatically route twice as much traffic to the primary region. Under the hood, the router takes the list of available deployments for that model, factors in their RPM weights, and shuffles them into a randomized list for that specific request. It tries the first deployment on the list. Because the randomization strictly respects the RPM limits you configured, your traffic distributes perfectly across all 5 regions over time, dodging the rate limits without the overhead of real-time monitoring. To set this up, you open your configuration file and set the routing strategy to Simple Shuffle. Then, in your model list, you define your 5 Azure endpoints. You give them all the exact same model name. Finally, you attach the RPM parameter to each endpoint definition with your desired weight. When your application calls the router using that model name, the router handles the math and the randomization automatically. You get the benefits of a distributed architecture without needing a Redis dependency. The best way to handle massive scale is often to trade perfect real-time tracking for stateless, statistically predictable randomization. Thanks for listening. Happy coding, everyone.